All right, we can get started.
Yeah.
All right, good afternoon, everyone.
I don't have your screen, though. You're not checking your screen.
Are we not on Zoom?
That's good?
You got it now?
No?
Oh, what
Try
is that?
try just the whole desktop then.
How about now?
No.
Yeah. Oh,
There we go. It's sharing, right? Okay.
Got it?
now.
All right. Let's do this. You got it?
Yeah.
Okay, gotcha. All right, good afternoon, everyone. We are Pod C and we got the workshop for serialization and data management. All right. First up on the agenda, we're just going to be going over some data serialization formats such as CSV, JSON, also applications such as SQLite and rsync. And I'll start us off with CSV. Now, CSV, that stands for comma separated values. It is a simple, very simple file format used to store tabular data. Oh, wait, let me see. Let me see if I can move this. It's covering some parts.
Be able to select an option and select the minimize at the top.
Minimize at the top. Gotcha. All right. It's a very simple file format used to store tabular data, such as databases or spreadsheets, into a more plain text format, right? Each line in the file, let me just show you for reference. Each line in the file represents some row of data. At the very top, we got a header, which signifies what the data underneath it represents, such as ID, names, departments, ages, and salaries. And this format is particularly useful for representing more simple relational data, right? Key reasons why you would want to use this is very simple, very versatile, and very lightweight, because CSV is a very simple format that stores data in a more structured way using rows and columns, and also using the commas to separate each line of data or each part of data, right? What makes it versatile is that it doesn't impose any specific data type on the values. And this flexibility allows for CVS to represent everything from simple text to numbers, dates, and even more complex data, which can be interpreted differently based on whatever application you're using or how you want the logic to perform with it. It's compatible with most coding languages, databases, and spreadsheet applications because most languages support some sort of library for it, or there's some person out there way before us that made something that could work with CSV. It is a very, very widely used exchange format because, yes, like I said, it was used by every other coding language. Every person before us has made something for it. Now, this is a very simple example of what a CSV file can look like. And a CSV file typically would contain some sort of line delimiter. It's not explicitly said in this picture, but there is a new line character at the end of every single thing, which shows that each row is its own form of data. There's a field delimiter, which is most commonly used as a comma, but is not limited to and could include some sort of character such as the pipe character, the semicolon character, or the colon character. And that's just used to separate the data from each other. There's also quote characters, as you can see with the names like John Doe, Jane Smith, and the departments such as finance and computer science. There are the quotes that signify that it is a string and not an integer, like something for age where it says 29 or 34. And optionally, most CSV headers, most people would not include a header, but for reference, I would include headers because it just makes it easier to see what each data means and what it relates to. Right. It's very simple to use CSV for Python because it is typically an already pre-installed package with Python. And all you need to do is put one line of text at the top of your file that says import CSV. Okay. Oh, is the video not showing up? There it is. Start the video. All right, as you can see, I have that very simple CSV file consisting of just the names, ID, ages, etc. And right now I'm just typing boilerplate Python stuff like defining my main function as well as initializing statements. All right, so right now I'm defining my read underscore CSV file function, which will be using a string parameter that is the name of the CSV file that I want to read. Right. So this is the simplest way to open a file in Python by using with open blank as file. It removes any unnecessary steps because in Python, you need to first open the file, read whatever you want to do with the file, and then close it afterwards. But using with will just get rid of all the unnecessary steps of opening and closing in one go. You can also see that in my initial with open statement, there's a file name underscore mode with R. That's just for the read mode. And for every reader, you need to create a CSV.reader object in order to read the file. Right? That's just me printing out the header, just so you know what information I'm dealing with in the CSV file. This right here, in this case, because I know what the CSV file contains, because I'm the one who created it, I know exactly where each index for each piece of info is at, and I'm just going to be printing each row out one by one with their ID, their name, their department, their age, as well as their salaries. And then I'm just going to be running at the bottom. And then you can see where the header is. You can see each information is being displayed. There it is. Now, with reading CSV, there's also appending CSV. Oh. There's appending to CSV files. Same as before, we had the original CSV file that I'm working with. And then I'm just defining my append CSV file with the string parameter of the file that I want to read. And you'll see there's a new letter in the mode that I changed, which is A, which is the append mode. And this just adds onto the end of the file. And then you'll notice that I'm adding an additional parameter into my write function. And these are constants that include something called quote all, quote minimum, etc. And this basically means that for every string that's in my CSV file, there's some sort of way that I could like interpret that. So in this case, I'm using quote strings to put quotes around only the strings and none of the integers or any of the numbers. This is a new command called write row, and this just adds whatever I put inside of that to the end of the file. So in this case, I'm adding a new ID, a new name, a new department, a new age, and a new salary. And once I run the command, or once I run the file, I'll go back to the CSV file and you'll see at the very bottom, that's where it got appended, the new information that I added. And then finally, this is the writing to CSV mode. Same as before, same CSV file. Right now, I'm defining again my write CSV file function. with the same parameter of the file that I want to write to. This one here is just deep, like random information that I just wanted to add. I just didn't feel like typing it out and wasting everyone's time. So W is the write mode, which is different from the pen. The reason it's different from the pen because with the pen, it adds to the end, but write truncates the file, meaning it will just erase everything in that file and start from the beginning, rewriting everything. Here, I'm just writing out the row. Or the header row, sorry. As you can see, I use different parameters. I use ID, name, major, age, and GPA to like represent a more student type of like file. And here I'm using the same quoting parameter where I would just put quotes around the strings rather than the integers. And for each row inside the data file or a data dictionary or list, sorry, it would just write out the row. I'll run the file. And then once I go back to the CSV file, you'll see everything has been replaced with everything that I just added. All right. Now, this is a more advanced example of CSV, where this one, instead of using like CSV.reader, you could use something called a dict reader, which would allow you to purposely get purposely get a string of text. So for instance, if my title was maybe like published date, I can get that exact part, take the date and turn it into a date time object, which is a different data type than integers, strings, which means that CSV is able to use more advanced, more complex data types rather than the more simpler ones. Best practices for using CSV files, using consistent structure, meaning you just have a more table-like structure. You have your header, you have the information, put commas in between, separate, make sure you use consistent like characters. Instead of switching up from commas to colons to semicolons, use the same character in between everyone. Handling missing data properly. I didn't put this in the thing, but there's a certain data type called null that you can use to put in missing data per se. So let's say there was a student that didn't have a student ID yet. Instead of putting just white space there, you could put the null type there, and that will handle it more properly. Character encoding, more secure data handling, and more efficient large file handling. Now, the second thing I want to go over is Pickle, which is a Python library. Now, Pickle is a Python-specific serialization format that implements protocols for serializing and deserializing Python objects. Now, serialization basically means pickling, but so I'll use it interchangeably, but that's what I mean. Pickling involves converting a Python object into a more byte stream. An example is like a pickle is a cucumber. You could slice the cucumber into many pieces, and you're basically representing those slices as bytes. So you just have one entire byte stream of cucumbers, if that makes sense. That's the example that I came up with, at least. But this includes not only simple data types, but you can use more complex custom classes or recursive data structures in pickling. The Pickle module recursively traverses all objects it encounters, and it translates this into a serialized format that could be written to a file and transmitted over to a network. Now, deserialization, that's unpickling. Unpickling converts that byte stream and turns it back into a Python object. And this process recreates the entire object structure, and it maintains the references between objects to accurately restore their original relationships. And then I have a little graphic at the bottom for you to see. You would take an object into a byte stream, pass it to whatever you want, and then if you want to unpickle it, it turns it from the byte stream back into an object. Now, Pickle is absurdly powerful when it comes to Python, since it provides unmatched flexibility. Using Pickle means you're allowed a high degree of flexibility, especially with serializing more complex data types. Not only can you serialize simple data types such as lists, dictionaries, you can also serialize more complex structures like functions, classes, or instances of classes. It also offers preservation of object states. Now, you have to keep in mind that Pickle isn't storing data. It is literally capturing the entire state of these objects. And that means that the attributes, methods, and even the states within methods will be saved and can be restored. And it also provides rapid prototyping. Because of the ease of saving and restoring states of Python objects, this allows for this fast flow of prototyping where us as developers, we can serialize and deserialize the data in between iterations of our code, which can speed up the testing and development of more complex data or more complex functions. Now, there's some use cases that we could use in terms of our class project. For example, we could save and load configuration settings. We can use Pickle to serialize configurations for things like the camera, such as like calibration data or refresh rates, resolution size, right? We can also, upon system startup for like the kiosks, we can unpickle configurations and have it more ease of startup with these predefined settings. We can also have it used for session data management. Now, I don't know exactly how the kiosk will operate with multiple users, but one particular use case that we could use is that we decide to somehow assign students with their own like personal accounts or something based on their student ID or student cards. We can personalize their kiosk experience by pickling and unpickling their interaction histories or their user preferences in between their logged sessions. They also cache frequently accessed data. Now, applications often involve repeated execution of costly operations, such as large database queries or complex calculations. And Pickle can just serialize the results of these operations and allow them to be saved and quickly retrieved, thus optimizing our application's performance. This would just reduce the load time and improve user experience by avoiding repeating processing. And just as I said before, Pickle can reduce the workload an operation has to do by avoiding repeating processes. And distributing objects across Python processes will, well, more than likely, our kiosk system will work under one like distributed system, meaning they'll share information amongst each other. So Pickling will just make it easier for those files and that data to be sent across different systems. Same as CSV, to import the Python package for Pickle, you just need to put one line of code at the top of your thing because by default, it should be already pre-installed with Python. So you just need to put import Pickle at the top of your file. Now at the top, I just have like a task list of sorts, just something that will say, this is this and is due this day. Yeah, I got you. I'm just defining my pickling and unpickling functions using a string parameter of the file that I want to pickle to. You'll see that I use a different mode here, WB. Adding a B changes the mode to work with binary because pickling, if you remember, converts an object into a byte stream. So you would need to use binary here. So this would just basically be write in binary. Pickle is very simple to use because you only need to remember this line of pickle.dump, where X is the file or where X is the data that you want to pickle and Y is the file to which you want to pickle to. This is now the unpickling function. This uses RB, which means read from binary, if you can interpret it as that. And here to unpickle an object, you would use pickle.load, where X is the pickle file that you want to unpickle. And here I'm just printing out the tasks. from the data above. When I run the function the first time, you'll see in the top left that there is now a pickle file that appears in the same directory of the file. And at the top, I'll just uncomment that one line and comment that line to unpickle. And then you'll see that it printed out my task list. Okay. Now, there are some drawbacks with Pickle because for as powerful Pickle is, there are something that prevents it from being a universally used tool. First of all, there is malicious code execution because one thing to be aware of is that Pickle has no system in place to determine whether or not a Pickle file is pickled with malicious intent. So it will, with no questions asked, unpickle the object that you give it, which could prove to be disastrous if someone were to, for instance, infiltrate our system with their own Pickle file that has malicious code that will probably break our system or reveal sensitive information. Now, we should only unpickle data that strictly comes from us, the developers, since we know specifically what we're working with. And we should also ensure that if we were to pickle data, we have a way to secure that data between us, because if it was public, there would be unauthorized mayhem that we would have to deal with. And that sucks a lot. Now, limitations for Pickle is that it is specifically Python. Pickle is inherently Python specific, which means that the serialized data cannot be easily used with other programming languages. This means if our application were to deploy the use of multiple other languages, such as maybe Java, that the Pickle file and the Pickle data would not be able to be translated across and used with the other languages that might need that data. It is also not suitable for long-term storage because the Pickle format is not standardized and it may change in between Python versions. And this lack of standardization can lead to compatibility issues, which would make Pickle unsuitable for long-term, where data might need to be accessed by different versions of Python over time. And now I'm going to send it off to someone else because a great alternative to this would be JSON.
I'll be taking care of the JSON part of the presentation. And so JSON, what is it? JSON is a lightweight data interchange format that's easy for humans to read and write, and also easy for machines to parse. It's based on a subset of JavaScript, but it is language independent, meaning it can be used with most programming languages. It's a popular data format used in web development, data analysis, and software engineering. So JSON, what it isn't though, is it's not a document format like a text file. It's not a programming language on its own, and it's not a markup language like Markdown. And also, it's not too overly complex to understand the syntax. So why would someone want to use JSON? JSON's easy to read and write because of its clear, structured, and lightweight syntax. It's essentially a collection of key value pairs similar to dictionaries or objects in many programming languages. JSON is not tied to any programming language. It is supported natively by many languages, including JavaScript, Python, Java, PHP, C#, and others. This makes it an ideal choice for data interchange between systems written in different languages. JSON is most commonly used format for web APIs when exchanging data between web applications and servers, such as sending or receiving data from RESTful APIs. JSON is typically used because it's lightweight and can easily represent the complex data structures needed for interactions. JSON's lightweight nature means that it doesn't carry unnecessary tags or formatting like XML does. This reduces the size of the data payload, making it ideal for transferring data in web applications, especially when dealing with bandwidth constraints. So some weaknesses of JSON would be its limited data types. JSON supports basic data types like strings, numbers, booleans, arrays, and objects. It does not support more complex data types like tuples or binary data directly. You need to convert these into a support format before you serialize them. An example here is shown that dates must be often converted to strings in this format when using JSON. You can't use in traditional date format. Lack of schema. JSON does not natively enforce a schema, which means you can have inconsistent data. It doesn't enforce strict data types, so errors can arise when expected data types are not adhered to. not ideal for large data structures. JSON becomes inefficient for very large data sets because it is text-based and not as compact as binary formats like Pickle or protocol buffers. Parsing and manipulating large JSON files in memory can be slow and memory intensive. And JSON, while widely used for data transmission, is vulnerable to security issues when dealing with untrusted sources. For instance, JSON data can be easily manipulated and may be used for injection attacks if not properly sanitized. Some use cases for JSON, like I mentioned, is data exchange and APIs. JSON is the de facto format for data exchange and RESTful APIs because it is human readable, lightweight, and works seamlessly with JavaScript. It's commonly used to send and receive data between client-side applications like web browsers and servers. In our example here, we have using JSON to fetch user profile data from a server using a REST API. Other use cases are configuration files, storing structured data, client-side data storage, logging events in structured systems, and NoSQL databases for semi-strings. And so we have an example here. You're supposed to be.
No sound.
Yeah, no, you're supposed to be sound. Okay.
Our library.
Sound's not going through the Zoom, it's coming out of the laptop.
Just full blast it.
Okay, today we're gonna be doing a very. I'll just explain it. I'll just, a simple tutorial. The example shows a simple tutorial on, on how to take a Python object and transform it into a JSON string. Python makes it very easy because they already have support with a JSON library. So first you would import the library up at the top and then initialize any object, then assign it to a variable. After that, you would run the dump function from the JSON library, and that would convert it into a JSON string. And then you print out your result, and down in the terminal, you can see that it spits out our JSON string. Down here. And very simple, very easy, very simple example, but it can also be done for a larger scale. And then our second example will be the exact reverse of that, showing how to take a JSON string and make it into a Python object. So up at the top, again, import your JSON library, and then you would take your JSON string and assign it to some variable. And then after you would run the loads function from the JSON library and print out what returns from the loads function, and your result will be our function wants to print out the age from our JSON string, and in the terminal you can see it prints out our age. And then final example. Okay, our final example is showing client data client server communication using Python, JSON, and Flask. And Flask is just a mini framework to show that allows you to take a HTML file and directly link it to a Python function. So if you want a particular action that happens on the web page to execute a certain instruction, it can do that. But first you need to install Flask. Flask is just do pip install Flask. And then the program sends a request for data, which will be sent as a JSON string, and then returns a response to that server. On the image, on the left side, it got cut off, but it just says the header says example using JSON, and there's a button that you click that sends a signal that sends a ping over to the server side. And on the terminal here, you can see that I clicked the button 3 times, and you can see the time interval that each time the ping was received. And so that's Steve, last example with showing client-server communication and how JSON is good for that. Next one is I'll also be doing SQLite. And SQLite, what is it? SQLite is a serverless, self-contained, file-based database engine. It stores the entire database, tables, indexes, and data included in a single file. It's a great choice for small to medium scale applications, embedded systems, and local storage needs. Some advantages of SQLite are zero configuration, no separate server process, lightweight and easy to embed in applications, ACID compliant, ensuring reliable transaction support, and well suited for small projects, mobile applications, or local storage. Some weaknesses of SQLite is designed for low to medium traffic environments and may struggle with high volumes of concurrent writes. SQLite stores the entire database in a single file. This can be an issue with very large databases, tens of gigabytes or more, as file corruption risks increase and backups or migrations can be slow. SQLite lacks certain advanced database features such as full text search, although it's available through extensions, replication and clustering, user-defined roles and permissions, stored procedures and triggers. SQLite is also limited by available RAM in the memory database. The entire database must fit in memory, which limits the size of in-memory database. This is based on the system's hardware. And for any type of local storage that we would use on the kiosks, SQLite could be a good option. Some use cases for SQLite would be it's ideal for embedded systems like mobile devices and desktop applications. Many Android and iOS apps use SQLite for storing user data locally, such as preferences, logs, or small data sets. SQLite also stores data locally for small-scale web or desktop applications, and it's useful for quickly testing SQL queries and database logic during the early stages of development. Developers use SQLite to prototype database interactions without setting up a full database management system like MySQL or PostgreSQL. And SQLite has strong storing sensor data or configuration data locally on small IoT devices like Raspberry Pis. A Raspberry Pi you could be used for a Raspberry Pi used to collect temperature sensor data stored in a SQLite database before syncing it to the cloud or the larger database. So SQLite is setting up SQLite in Python. It's pretty often pre-installed on many systems. And Python comes with a SQLite library as part of the standard library, so no additional installation is required. But if you do have to install it, the command is down here, pip install SQLite 3. And so connecting to the SQLite database, it uses a file-based approach where the database is stored in a file, and a new one will be created if it doesn't already exist. So this little section of Python code here, at the top, it imports our SQLite library, and then we set up a connection through this by using the connect function, and we pass in the parameter of what our file name will be, or a database name, and then we create a cursor to interact with the database by invoking the cursor function, and we print out for the sake of the user that you're connected to the database. And then creating tables, it's very simple. It's using SQL, and so you just use basic SQL to create your table, and after that, you make your table whatever it be. For here, it's ID, name, age, and grade, and you also specify the data types for your SQL table. And then you do the commit function to commit any changes that you did into the database. And then you print out that the table is created successfully for the user. And then inserting data, you use the execute function and you pass in the parameter in the insert statements. And then you have to lay out in the parentheses how many columns there would be. And then also include in the parameters data that you're passing into for each column. And then you run the commit function again and you want to, anytime you make a change to the database, you want to do the commit function so that nothing gets lost and you don't have to do your work all over again. And then for fetching and filtering data for if you're trying to retrieve any data from the database, you run the execute function and pass in your select statement from whatever table that you are trying to pull data from. And then for any rows, you just do the fetch all function, and then you just print out the row. So, but if you're trying to fetch specific data, you have to filter it and use a select state. You run the same stuff from the first, from the top of the function, and you select it from where you're selecting it from, and then you pass in an additional parameter specifying what type of data you're looking for. Right here, it's looking for students where their grade is an A, and you run again the fetch all function, and it should print out students who have an A compared to the top one who's just going to print out all students. And then updating data, you again run the execute function, pass in the update statement, and then you update what you put in what you're trying to update. And this one is student's age, and then where you have to also label where you are updating it. And then you again commit, because you want to commit every change you make. And then for deleting data and closing your connection to the database after you're finished working on it, you run the execute function yet again, and you just pass in delete where you're trying to delete data from, what table, and then what column you're also trying to delete the data from. And it's important to specify what table and column, because that it would have no way of deciding where to delete information from. And then to close your connection, you just run the connection close function, and that will close your connection to the database, and you won't be making any more changes to it. And now I'll be passing it off to rsync.
All right, so I'm gonna be talking about rsync. What is rsync? Rsync is a Linux-based tool that can be used to sync files between remote and local servers. rsync has many options that can help you define the connections you make. rsync is an open source synchronization program. It's designed to maintain a mirror of a directory. It is a very advanced tool, an intelligent data transfer algorithm that can be used to make backups or to copy files to another disk, as I'll show in the next couple of slides, how I transferred data between two folders, and different ways of doing that and manipulating the way you do it to get what you want. Why is it used? For two reasons. Efficiency. If a version of a file already exists at the destination, it only changes portions that are being transferred. So if you have two files, and your source file is the one that you're transferring data to your destination file, and let's say you have five files in there, and you want to transfer them all to the destination file, and they already have two of them already in there, it wouldn't have to do all of it. Since it already has two, just do what it's needed and what it needs to get. So it's very efficient and fast at doing that. And for robustness in environments with slow connections or random hardware failures, especially disks that become non-operational after heating up, rsync can resume transfers that are interrupted. So if you have a lot of files that you're trying to sync over to another directory, and let's say your internet goes out or you have a network failure, it won't have to do it all again. It would it saves it all, and it starts from where it left off, basically. So what do you need to download? Mac already has it installed, so I'd have to do nothing. For Linux, for RPM-based Linux machines, you have to do sudo yum install rsync. And for the Debian-based Linux machines, you have to do sudo apt-get install rsync. And for Windows, I linked a video on how to do it since it was multiple steps. And what are some rsync flags and utilities? So flags are basically how you so you write rsync and you write the flag to get what you want to happen. So you have -A copies files recursively and preserves ownership of files when files are copied. I'll be demonstrating that in the video after. Dry run, I didn't use this, but I feel like this would be a great tool because it runs a trial of the command and you won't actually make the changes. So if you did something that you didn't want to do, then you could not actually do it. So that's really cool. They have the delete tag, delete any outrageous files from the destination directory. So when you delete something from a file when you delete something from the destination file, you're trying to copy essentially what the source files you have into destination file. And if you have something that is not in the source file, it will delete it automatically. So that's something to be aware of when you're doing that. -E tells rsync what shell to use. Excludes all of a specific file type. Replace file type with the actual file type that should be excluded. -H produces easy readable output, not just numbers. I'd show that one too. -progress shows a transfer progress as the command is being run. That one kind of ties into -V because -V runs the verbose version of the command and essentially just prints out all the files onto the terminal, what is being transferred between your two directories. And progress just shows you like the speed of it and how fast it's going and the size of it. So it gives you more information about what is actually happening behind the scenes. -Q runs the quiet version of the command. All the processes that you are running will be run in the background and will not be shown. -V compress the data and syncs it. Okay. Let's see this works. All right, so what I plan on showing throughout this video is some of different flags you can use with rsync. So right now I have two folders, a source folder and a destination folder. I have a couple of JPEG files that are just pictures of my dog. And what I'm going to try to do is sync the source file into destination file and show the different flags that you can use and different ways of doing it. So the first thing, if you want to transfer only one JPEG file or any sort of file into another folder, we would first have to see into our desktop. And then we could type rsync source, which is what we're getting our files from, /01 JPEG. Then what would follow that would be the destination folder. And we just put destination. So as you can see, one of the JPEG files successfully transferred over. And yeah, that was what we were trying to do. So I can go ahead and delete this. And so now we can try syncing all the files in the source content to our destination folder. So we can do sync source destination. And it says skipping directory source. This just means that we have to specify the recursive flag to copy the entire directory over from the source to the destination folder. And we can do that by using rsync. And with our /r flag, then when we type source, then destination. And then you can see that there appears the source folder inside our destination folder. And that wasn't exactly what we're trying to do. And you can see all our files are here. So what we were trying to do was to copy all the content inside the source folder, not the whole source folder itself. So to do that, we have to be very careful with our slashes, and that's the reason why the source folder, the entire source folder was transferred over. So instead we could do same thing and just put a slash behind that. Yeah, just like that, we get all of our files in our source folder, and that's how you would transfer your files from your source to any other file, any other directory. So we can go ahead and delete this. Another thing we could do is look at the timestamps. I deleted, but let me just bring it back. As you can see, the timestamps show the actual time that it is right now. It doesn't show the times that they were. It doesn't show the same times. So if you want to have the same times for the timestamps, you could use the A flag, and you would use like this. Just like that, it matches exactly how the source folder looks, including the timestamps. And it's now a one-to-one relationship with the source folder and destination folder. So you can try something else. Another cool thing we can do with rsync is to make it verbose, which essentially just prints out the file names on the terminal that are being copied over from the source file to the destination file. And we can do that by typing rsync, and you just add the V letter behind the A, and you do source, and it copies down all the JPEG files that I'm transferring over, and that's really cool, really nice, neat thing to use. And a way to make that even better would be to show how fast it's copying, and when it's done copying each one, then it'll go on to the next one. And the way to do that would be to add the progress tag. So that would go by doing rsync again. Keep your A 2 dashes before progress. Okay, so it shows how fast everything is copying over, and it does that one by one. You could also see the sizes right here and right here. And the sizes are in bytes, so it's not really readable. So if you want to make it more human readable, there's also an H flag that you could use that will switch the bytes something that makes more sense. Do that by sync again, keep the A, add the H, progress, source, destination. And it does the same thing, but as you can see, it goes to megabytes, and kilobytes. So that's something interesting that it does. And now another cool thing that you can do with rsync would be if you want to sort of simulate a syncing type of operation, and you could do that with the delete flag, and you could go and do it like this. Source. So nothing happens because they're exactly the same. But if we add something to the destination folder, then something different will happen. You can see we added a text file in destination folder. So now if we run the same command again, it will delete the text file and essentially just wants to create a exact from the source file, and it wants to have the same thing on both sides. And another way we can show that would be by just having the text file. And then if we run it again, it deletes it and it replaces it with the source files that are to the left of it. So that's a cool thing we could use with rsync. And lastly, the last thing I want to show would be the remove command. Sometimes you might want to make a one-way transfer where when you copy over the content in your source file into the destination file, and once it has been successfully transferred, it's going to remove the content from the source file. So the way that works is by doing the same thing, A or H, remove, add remove, source, files, um, you're supposed to add should be right there. So try that one more time. Just like that, it transferred everything from source to destination and removed everything in the source file. And yeah, that was basically what I wanted to show. So the main goal of the video was to show some of the cool things that can be done when transferring data between two directories. And yeah, thank you for watching.
All right. That's the end of our presentation. Now we just want to give y'all one simple deliverable. I just need y'all to create a file using one of the feature formats in our presentation. And that just needs to include your pod ID and your pod description. So what you do or like what your workshop was about, and also the name of the members, and just push it to us. That's it. All right. Thanks for watching.
Did anyone have any questions about data serialization, data management, or please?
What was the drawback to using CSV?
The drawback to using CSV, malicious code execution. So, no, that was Pickle. Honestly, the drawback to CSV is that because it's very simple, right? There's not like a more, dang, wait, I don't think I thought of a drawback. It's perfect to use. Let me say that.
Perfect.
It's a flat file, right?
Yeah, it's a
So
very
gonna be
flat file.
Hard, it doesn't have the services that a database language would allow you in terms of the query
I know,
power.
right.
I will say,
That makes sense.
one thing that you should be aware of, if you do work with CSV data, especially in Python, there's a really valuable package called pandas that allows you to import CSV into what's called the data frame, and it does give you query-like powers onto that data frame. But then the limitation is that that data frame has to exist in memory.
Hmm.
Whereas the benefit of a database is that it is not locally like run in the same memory space as necessarily your application. And so you could potentially have multiple servers communicate with a single database, and that's your one source of truth that every service can then communicate with. A lot of these other services we've looked at are all locally run, and they're all locally loaded into the memory. So it has to happen on that particular machine to access the data. The wonderful thing about a database is that it can be shared data across multiple machines, and it's all updated and synchronized.
Just considering the resources of the Raspberry Pi.
Hmm.
Now, the Raspberry Pis that we have, just so that you know, is we've got the most up-to-date version that they have. So the Raspberry Pi 5s, they're not just Raspberry Pi 5s, they also have 8 gigs of RAM. But with that said, a lot of that's going to be used by the Leap Motion. So yeah, you probably want to have a dedicated maybe database that all the client to the server connects to make any queries to. And that's safer anyway. That way you don't have any data loss if a particular client fails.
All right. Any other questions?
Hey, do we need, Linux installed on our PCs on this,
Pickle or CSV?
so Arsenic,
Rsync?
The what?
did you need Linux installed on these Arsenic?
So it said that most Linux would have it, but if you just, I had it, yeah, you just put that in your terminal and that should work.
I see. Thank you.
All right.
Any other questions? Okay, well. We'll do the last week of workshops next week, and then we will start on
me just
actually.
put it-
implementing everything.
Yeah, you're good.
Let me stop.
You did a good job.
Thank you.
Did a great job, Alex. Yeah, you did a good job. You did a good job too.